All right, so as I said, we will then begin to just explain uh what in general terms. I'll start with the ellipse. And we'll build up to, that's if time allows, to the hyperbola. But it's key. You don't want to rush into just answering the questions if you do not understand what exactly is going on. So an ellipse is just a conic section that looks more of a stretched out circle, or others would call, what do you call it, an oval, something like this. This is an ellipse. This is how the ellipse would look. And of course, just like any other conic section, the ellipse as well is defined by what? By an equation. So we have that. So at first we'll start looking at the ellipse, which is centered at 0, 0. That's what we'll look at first. An ellipse centered at 0, 0. So now we have an ellipse that is centered at 0, 0. That's our center. Our general form of the equation is going to be x squared over a squared plus y squared over b squared equal to 1. So this is going to be the general form of our ellipse. That is at center 0, 1. Then this, of course, this ellipse, the one which we've written, this general equation, is the one where we have the ellipse sitting in the horizontal plane like that. So for the horizontal plane, we have that our a squared is going to be, so for it to sit in the horizontal plane, you have to have your a to be greater than your b. Then when your b is greater than your a, then you have that your ellipse is going to sit in the vertical axis like that. So let's have a general, okay, so a general look, let's say starting with the one in the in the horizontal plane. So if I have this here as my x or y plane, then I have my ellipse sit here in the x or y plane. Remember, it's centered at 0, 0. So these endpoints that are here, these are what we call the vertices. Those are the vertices for this ellipse. And the vertices are given, so if it's in the horizontal plane like this one, it's just going to be given by, so it's in x, so that's going to be a, 0 this side, and this side, since it's negative, that will be negative a, 0. So this is what you get. Then in the y axis, here in the y axis, you have what we are going, what we're calling the y axis is our minor diagonal in this case when you have this equation like this.
Guys, I'm becoming, let me just take some.
You're saying this is the y will be the minor diagonal, and it's gonna be just given by 0, b there, and 0, negative b. So I'm sure you can see there's the a there and the b there. So now, how do we get there's another value which we need to get, which is our c, and that is our focus. So our focus, our c, is going to be gotten by the equation c squared being equal to, that would be a squared minus b squared. This is how we get our c squared, and this is how we get our c. So then our c is just going to be root of a squared minus b squared. This is how you get your c. And your c, again, you get plus minus c like this. If it's in this case, it sits in the, it's going to sit there in the x. So meaning you have, so an ellipse has two, and it's okay, an ellipse has what we call foci. Yeah, so foci, that's plural for us, is focus. So foci, there are two of them. So meaning you have one in the negative, that is going to be negative c, 0, and you have the other one that is going to sit at c comma 0 like that. So this is going to be your f. So f1, and you're saying you want your f2. These are your foci which you have, and so this is how the general picture of it is going to what is going to look. This is what you're going to have when you have it at 0 comma 0. So now for an easy question, let's look at an easy question here. Let's say we are taught to graph, and we are taught to graph. Let us graph the equation x squared over 25 plus y squared over 16 is equal to what? To 1. So they taught you to graph this ellipse here. Given this ellipse, and you're taught to what? To graph. So now how do you graph this ellipse? So remember, you need to identify. So when you identify, this here is going to be what? Your a squared, and that here you identify to be your b squared. So we can find our c squared by saying a squared minus b squared, and this here is going to be 25 minus 16. And when we compute this, we get that we have our c to be, subtract that, you get 9. And of course, introducing the root there, you just get plus minus what? 3. So plus minus 3, it is centered, so the center is 0 comma 0. So, and it's, we see that our a sits under x. Our a sits under x. So how you notice this one, for this one, whether your ellipse is going to be in the horizontal plane or it's going to be in the vertical plane, you check the number which is big. So 25 here is bigger than 16. So meaning the bigger number, where the bigger number is, that's where it's under x. So that's where your what is going to sit, your ellipse. So when you draw your ellipse, you're saying, of course, you can get more accurate points, because we see our A. Let's check our A. So this is our C, which we found, meaning our focus will be plus minus 3 comma 0. Then I have that my what is my major diagonal. My major diagonal is going to have so major is A here. So you have your A there, plus minus. So you have your A squared, meaning your A is going to be root of what? Over 25, and that will give you 5. So you get plus minus 5 there. This is in your major diagonal. Your minor diagonal, you have 16. B there is just going to be root of 16, which is just going to give you 4. So meaning you have in your minor plus minus, okay, so 0, since it's in the y, that will be plus minus 4 now. So you have that here, you have your y, and there you have your x. So when you're going to what? Compute, so not compute, when you're going to sketch, so you have, it's going to pass there to go all the way, then comes like that. And so I'm approximating. You can get a better approximation than this. So meaning this part here, this is 0 comma what? Comma 4, because it's in the minor, and there, this here where it crosses, that is 0 comma negative 4. Then our vertices in the major diagonal, we have 5 comma 0, and the other side we have negative 5 comma 0. Then our focus are inside here. So we have it that we have here f1 to b, so that will be negative 3 comma 0. Then the other one, this side again, you have that to be 3 comma 0, and this is how you want to sketch your ellipse in the y, in the x-axis like this. So you can do the same, in fact, with when you have it in sitting in the y. So let us just use the same question, just that we are able to easily do it. So when you check this, meaning you have that the 16 is going to be here, and your 25 is going to be there. So now, when it's in this case, this still remains to be your a squared. That remains to be your b squared. So in the first case, we had a to be greater than b, but this now is our case where I have b greater than what? Than a. So now, when we are still going, when finding our c squared in this case, you're finding your c squared, it's going to be b squared minus what? A squared. So instead of the way we had it at first, yeah, it's going to be the other way around. So they just swap like this. This is how it's going to be. And of course, you know, this still is going to give us that our C is going to be, so 25 minus that gives you 9, then you just get that you have plus minus what? 3. But now in this case, the bigger number sits under what? Y, meaning we are graphing in the what? In the y-axis. That's where our ellipse is going to sit. So now if it's going to sit there in the y like this, what values are we going to get? What point? So look at this. So the major diagonal, meaning your major diagonal now is given by what? By b. It's given by b, and that is still what? 5. So b, when you check your b is going to be equal to, you have plus minus what? 5, those values. And your a is going to be equal to plus minus 4. So in the major diagonal where it sits, meaning it cuts here going down like that. Okay, so these values where it has cut there, that there on top is 0, comma 5. And you have down there to be 0, comma negative 5. Then in the sides where it is cutting here, you have that will be negative 4, comma 0, and there you have 4, comma 0. So now your C in this case, because the bigger number was under Y, your C means you're going to be adding to the 0, comma 0, which you're adding here. You're adding in the Y, so you add it here, so it will be plus minus this side where it is, just the way we did with B here. So meaning you get that your points are going to be here, where you have 2 of your axis foci. So you say F1, and this part here, this is yellow here, you're going to have that you have 0, comma negative 3, and you have the other one to be 0, comma 3 like this, and this will be your F2. So this is how generally the ellipse is going to look in the X and in the Y. But now there are times when it shifts. So there are times when it shifts. What do we do? I want to now pick a question from the tutorial sheet. Just a minute. That question. Okay, so I don't know if can you see question the question which reads in question 4 and through to 12. Can you see this part here?
No, sir.
Okay. So let me just let me do this, and I'll add that question. Okay, so this is the question that I'm talking about. I've just gotten it from the same tutorial sheet. Let me erase this. So this should give us an ellipse. Let me just enlarge this. Okay, so can you see the question now? Are we able to see the question?
Yes.
Okay, thank you. So this is the question which we have here, and for this question, we need to identify what conic section first it is. So remember, how do we do this? We have to complete the square on the like term. So we have 9x squared there. I can group it with 90x here. Then I have plus 25y squared minus 150y plus 225 equal to 0. So here I can factor out the 9. I remain with x squared minus, that would be 10x. Then I can factor out 25 here, such that I have y squared and I'll have that is going to just be minus 6y, then plus 225 equal to 0. Then I'll have that I complete the square on what is here inside. I can write my x here, then half this, that will be 5 squared. Then I square the half of 10, which is 5. So 5 squared is just going to give me 25. So I get 25 there. Close that. Plus 2, plus 25, then y minus, that will be 3. Then minus 3 squared is just 9. Then plus 225 equal to 0. Then I can expand this and I have 9x minus 5 squared. Then that will give me 225 plus 25. There's a squared there. Y minus 3 square. Then I have minus 225 plus 225 equal to 0. So this, of course, it gives me 0. Gives me 0. Then I can take this other one, the other side, such that I remain with 9x minus 5 squared plus 25. I have y minus 3 squared equal to 225. So from here now, I have to divide everywhere, the entire thing, in fact, by 225. So the other side here, I'll just get that will be equal to 1. So I'll get that this side, I just get 1. And when I check the other one, here 9 divides into 225, that's 25 times. So I have x minus 5 squared over 25. Then I'll have plus, that will be y minus 3 squared over 9. So this is what I get. And obviously I can see that this is an equation of an ellipse. It's an equation of an ellipse. There's a plus sign in between here. It's equal to 1, and you have this here being your a squared and there being your b squared. So this is what you get. But now this why I picked out this one is because you observe that the center is no longer 0, 0. The center has shifted from 0, 0 to these points here, which you have. So how do you get the new center? You just equate the first part where you have x minus 5, this to be equal to 0, and you have x equal to what? To 5. Then the next one, the other one, which is y minus 3 equal to 0, and you just get y is equal to what? To 3, meaning your center is 5, 3. So this is the center which we get. So if we can find our c here. So we say c squared is just going to be 25 minus 9, and you get c squared equal to 16, and c is going to just be plus minus 4. This is what you get, plus minus 4. And now for this and our a, of course, you know that your a is just going to be plus minus 5, and your b, which is your minor diagonal. So this is going to sit in the x because the bigger number is under x there. Your minor diagonal is just going to be plus minus 3. So this is what you get. So these are the values that will be there, and these are not the exact ones because this here has a shift. Remember, it has shifted, and it's no longer at 0, 0, but it's at this is the center, meaning because it's going to sit in the x. So our focus or is going to be, we say where, since it's sitting in the x, so where there is 5 here like this, we say that should be plus minus that is plus minus, it's what, 4, plus minus 4. Okay, plus minus 4, then comma 3. That's the shift that's there. Then for vertices, you have the one for the major. It's going to be still 5 plus minus 5. Then the other one is going to be 5 comma 3 plus minus 3, like that. So this is what you get, and this is how you get the other those points. So you can then sketch this, so you have it like this. Okay, so locate your center. 5, so this is 5, and 3, you go up a bit, so we say that is there. So if this is our, it says 5 in the x, and that is our 3 there, so that will be our center. Then our focus, okay, let's not first do the focus, but let's say our vertices are going to be, so when we add this here, we get 10. So it will be 10 comma 3. So let's say our 10 is here. So let's say our 10 is here, then you get that to be there. Then for the other one, when you subtract 5 minus 5, you just get 0, and that would be 0 comma 3, and that would be at that point. So this is what is going to be your vertices. So that is in the major diagonal, and let me just write a dotted line here, like this in between. So this is, we shifted, so our center is the one in between, and just writing that dotted line. Then in the minor diagonal, we have this here. So it's going to be at this point, same 5, but then when we add 3 plus 3 is going to give us, plus 3 is going to give us 6. So let's say our 6 is somewhere here. I think I've gone too much, but yeah, let's say 6 somewhere there. So that would be our 6. When we subtract, we get it at what? At 3 minus 3 will be 0. So we have 5 comma 0, which is going to be here. So if I join these points, going to have something like this, passing through there, then hitting that point, then going like that, and up to like that. This is what I get. Then I've of course not forgetting the focus which we have. So when we add 5 plus 4, we get 9 comma 3. So 9 comma 3, we say if our 9 is somewhere here, so meaning this point here is going to be my one of my focus. So I can say this is going to be my F2, and my F2 will be that would be 9 comma what? 9 comma 3, like that. Then I check this other one. When we subtract 5 minus 4, I get 1 comma, the another one will be 3. So say my 1 is somewhere very close to there, so this is going to be my 1, and I say this is my F1, and that is given by 1 comma 3. And this here is going to, that is how your ellipse is going to sit, and you found the necessary things which you need when it comes to discussing here, which is yeah, the focus, the vertices, and all that. I don't know now. Are we clear on how we find the ellipse? How to sketch? How you find? So generally, this is all about the ellipse. If it's going to be in the y, if this swap, like if you had, it's just going to sit in the vertical axis, which is the y-axis. Yeah. Are we clear? Do you have any question? Okay, so the silence means we are clear. Let's then look at. So we might not even answer most of these questions here today, because I want you guys to really understand the concept. Let's look at the hyperbola now. So for the hyperbola, So the hyperbola is the one which kind of looks where you, if I have my x and I have my x and y axis there, x and y. So it's going to, it either sits, it's gonna be like that, or it's going to be in the y, it's going to be like that. More like you're having two parabolas, one there facing the other side, one facing the other side. And the general form, so when it is centered at 0, 0, so we're starting from, is going to be x squared over a squared, then that is going to be minus y squared over uh, b squared, then that equal to 1. So when you have it like this, uh, you have it like this, where x is positive, then it's going to sit in the horizontal axis. So if the meeting cuts, which it will cut in the next 10 minutes, just rejoin. Yeah, so it sits in the x-axis. Then when we have that, it's when we have that y is positive now, we have a squared over um, like that, then minus x squared over b squared equal to 1. It's going to be this case, the second case, which we have. This is when that is negative like that. So this is what we get for this one. And for this one, our c squared is just computed as x squared plus b squared. Notice the difference with that of the ellipse. For the hyperbola, it's computed like this. And now with this one, we also have the asymptotes. So you also have to find the asymptotes, and the asymptotes. So we're looking at a point where we have 0, 0. The asymptotes are just going to be given by y is equal to, so you have plus minus b over a. So b over a is in this first situation when you have it like this. And when you have it in the second situation, it's going to be y is equal to plus minus a over b like this. I forgot x there, x there. So this is how it's going to look. I think okay, let's use the same example, the easy one, then you get one from the tutorial sheet, then yeah, we'll call it a day. So want to use just like the one we used with the ellipse, but then there'll be a minus sign there in between. So the easy one, such that we don't make our life complicated. We said x squared over 25 minus y squared over, we're using 16, and we said 1 there. So we're looking in a case where it is 0, 0, first of all. So our a squared is this one, and our b squared is there. So, is that a question? Kindly mute your mic. Okay. So, yeah, we're saying this is our a squared, and that's our b squared there. So, to get our c squared, we're saying that is going to be given by a squared plus b squared like that. And you have 25 plus, okay, let me use 9 such that it should, let me use 9 and for my suiting. Okay, so for my liking, allow me to use 16 and 9. I'll use 16 and 9. Okay, so this then, this is our a squared, and that's our b squared, such that we have c squared. When we add our a squared, 16. I've used this one such that we have we don't have roots and anything, just for this example, of course. So 16 then plus 9 there. Then our c, which means this is c squared, and this will be 25. Then our c is just going to be equal to plus minus 5. This is what you want, what you get to be your c. And okay, this is what you get to be your c, of course, yes. Then your a, meaning your a is just going to be plus minus, when you check that one, that is 4. Yes, your x is going to be, your a, I mean, plus minus 4. Is that a question? Is the question, okay, so there's a question, is the equation of the ellipse and the hyperbola the same? No, they are different. Check the sign there is what makes them different. There's a negative for the hyperbola, for the ellipse there's a positive sign. So this is what you get here. And to sketch this one, uh, so to sketch this one, remember it's centered at 0, 0, which is there. So I have my y and my x here. Then my vertex, since this one is sitting in the x, so my vertex, as I found, it's this one here. So that is going to be, I'll have negative 4 here, and the other one is going to be 4. So these are my my vertices. And in the, I forgot of b. So b, we have that b will have plus minus 9, plus minus 3, I mean, root of, yeah, plus minus 3 is what we have. So meaning here we will have, this side we have positive 3, and down there we have negative 3. Remember, my axis is not really drawn to scale. So easy, just make yourself a box like this, like that, and like that, there, like that, and all the way like that. Then remember that you also have to find your asymptotes, and the asymptotes in this case it's given by y equal to, so plus minus b over a x. So your b is 3. So this will be y equal to 3 over your a is 4, then x like that, plus minus. So this is what is our asymptote. And our asymptotes will pass through the center because it is centered at 0, 0, so which is the origin in this case. So you write that, it's going to pass here, you write it in white. Okay, so passing there like that all the way, and going like that there, like that. So this is how your asymptotes are going to be, and you can label them to just say this one going this side. Even if you label, just label them as 3 plus minus 3 over 4x. Yes. Then you now have to write the 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 more of the, like, the parabolas. So they will follow this. Of course, they are not, these are the asymptotes, so they're not going to oversee them. So they'll come like that. And of course, the vertex is at 4. So it's going to pass there at 4 and go like that. And it's going to do the same the other side, like that and like that. So remember our focus. We have our focus, one of them, this side, which is at negative 5, 0. Then you have the other one at here, which is, you have it at 5, 0. So this is what you have, and this is how you'd sketch it if it's at 0, 0, like this. If it's inverted, where you have, it's like this, y squared over, so you have y squared maybe over So these just swap. Let's say they just swap where like this. Then you have minus x squared over 16. So you take this to be your a squared and you take this to be your b squared. And you see, but that because our c squared is given by a squared plus b squared, this doesn't affect what we're going to get as our c in either cases. But this for this time around, because the a or the number the one which is positive is y, it means that it's going to sit in the y direction. I think you can just sketch that one as well, just for you to have a clear picture of how it looks. Okay, so to sketch this, you're going to have that